probability laws. So first law is addition laws of probability. So here we have two cases. For first one, if we consider two events A and B and they are disjoint events, that means they don't have any common points. So in that case, if we want to find out the probability of either event A or event B will occur, then we can write probability of A union B equals to probability of A plus probability of B. So if we consider it up to n events, so A, B, C, D up to Z, so we can write the probability that either event A or event B or event C or up to event Z will occur is probability of A union B union C union up to Z equals to probability of A plus probability of B plus probability of C plus up to probability of Z. So these all are for disjoint events. Now, if we have joint events, that means the events, they have few common points. So if we consider it in the case of two events A and B, so the probability that either event A or event B or both A and B will occur is probability of A union B equals to probability of A plus probability of B minus probability of A intersection B. So if we consider this one with the disjoint events A and B, so see, there we don't have this common part because they are disjoint, they don't have any common points. But here A and B are joint events, that means they have a common part. That's why we have this formula. So similarly, if we consider it for three events, then we can write probability of A union B union C equals to probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of A intersection C plus probability of A intersection B intersection C. So this is the additive property of the probability law. Now, if we consider one example, so if in a company 60% of the employees have motorcycle and 40% have car and 20% of them have both. So if an employee is selected randomly from that company, then what is the probability that the employee has either motorcycle or private car? Also, we have to find out the probability that the employee has neither motorcycle nor private car. So first of all, we list the information that is given here. So first of all, we define the events. Say for example, M, we considered that the randomly selected employee has motorcycle, and C equals to the randomly selected employee has car. So see the diagram. So C is here and M is here, and see they have some common points, right? So the information that is given in our question is probability of M is 60%. That means 60 over 100. And the person who has car, the probability is 40%. That means 40 over 100.4. And the person who has both, that means probability of M intersection C, it is 20%. That means 0.2. So now for first one, C, we have to find out that the person has either motorcycle or private car or both, right? So this part we have to find out. So this is the formula, we have already known it from our previous slide. So we just put the values and we will have the probability value as 0.8. That means there is 80% chances that the person has either motorcycle or private car. Now the next question is, the person has neither motorcycle nor private car. So we have to find out this area, right? So that means probability of M union C complement. So that means we know the total probability is, the whole probability for the whole set is 1. So 1 minus those who have either motorcycle or private car or both. So we can say 1 minus 0.8, that means 0.2. So we can say 20% of the person has neither motorcycle nor private